First thing is to look at the definition of a relation. A relation is a set of ordered pairs such as x, comma, y. And it doesn't always have to be mathematical. It can be anything where you're relating one thing to another thing. And it can be, you can have a relation that is discrete, which means it is a countable set. Like it could be a finite set of pairs that you can just list and count, and there's only a few points. It could be countable and infinite, meaning that there are gaps in between pairs. So you can have a list of ordered pairs. You can have a relation represented as a graph of dots on an xy plane, for instance. You can also have continuous relations, which would have an infinite set of pairs. And not only are they infinite, but they're not ones that you can list out. You can have an infinite set that is listable, such as like all the odd integers. So all the odd integers paired with maybe all the even integers. So that would be, oops, that's 3, 4, and 5, 6, or something like that. And you could establish a pattern there. And even though you might not be able to write down every single pairing without, because you would be doing it infinitely, you would never stop. It's a pattern that has no end to it. That would be infinite, but it would not be continuous. That would actually be discrete because there are gaps in between, or you can count them. Infinite sets, which are also continuous, are ones that need to be represented as an equation or a graph of a continuous curve. All right, so the next thing to look at is how relations, functions, and inverse functions relate to one another. Well, everything falls under the heading of a relation, but some relations are not functions and some are. And then you also have some functions that are invertible, which means that an inverse function exists, which will undo the original function. And some functions are not invertible. So we're going to learn about the different kinds of relations and functions we can have. And I'm going to use examples of vending machines, a great way to understand what a function is in a less abstract way. And we will be reviewing how I introduced it to you earlier in the term, just understanding what a function is. But we will also use another scenario to understand a function that is not invertible. I guess you could call it the ideal situation because it is all three. It is a relation, the relation is a function, and it can be inverted, or an inverse function exists for this function. So the reason that it is a relation is because it is a set of ordered pairs. So if we wanted to call this f of x, just listing it as a set of ordered pairs, you have the ordered pairs that are listed right here. 2 related to C, 3 related to R for raisins, and 4 related to G for granola. All right, and that's what I have right here. So that's a relation, and it's a function because there are no repeated x values, or in other words, there are no input values or no buttons that are assigned to more than one snack. So that's what makes it a function. Okay, so we have a relation, it's a function, and it's invertible because it is also monogamous the other direction. So notice that there are no repeats of any of the second coordinates. So each snack is coordinated to one and only one input, or one button that you would push to get a snack. So it is all three. It is a relation that is a functional and invertible. The number 1 or the number 2. So this will definitely give me pretzels, and this will definitely give me pretzels. So either way, as a user, I know for sure how to get pretzels from either one of these. Okay, so that's functional. However, it's not invertible. because if I wanted to go the other way around and say, well, if you're eating a snack of pretzels, you must have pushed button number 1. Nope, can't say that anymore because you could have also pushed button number 2. So there's 2 possible outcomes if you're starting from pretzels. So this is not one-to-one. And that's the formal way of saying that it is not invertible. So F inverse does not exist for this one. You can't invert this one. And the next example is a program error. So this is a true malfunction, which it's not even a function this time. It's a relation still, of course, because one is related to pretzels, but one is also related to cookies. And so this is not something where I can push the number 1 and be certain of my snack. I want pretzels, but I'm uncertain of the outcome. All right, so that is a relation. It is not functional, and of course, then it is not invertible. All right, so a summary of this is how to identify functions and determine whether a function is invertible, or the proper way to say it is one-to-one. So I have here the relation type, the graphical test you can use, and properties. So if you have a relation and you want to know if it's a function, then you can use the vertical line test. And the reason you can do that is because if a function is not or if a relation is not a function like this, and you draw a vertical line through here, then you're going to find 2 values such as 1 and 1 and 1 and -1. So this has 1 being mapped to 1 and also being mapped to -1. So that is not a function, because when you have the input 1 or the horizontal location of 1, you don't know for certain whether you should be up here or over down here on the function. So if you have a relation that is graphically represented and you draw a vertical line through it and it intersects at more than one place, then it fails the vertical line test and it is not a function. Right? Because you don't want to have repeated x's. Like right here we have repeated x's. So you're supposed to have no repeated x's, otherwise it's not a function. But you are allowed to have repeated y values. So that could be an example like this one. So it is a function because no matter where I draw a vertical line, I'm only going to be ever intersecting the curve at one place. So each x value is only going to be assigned one vertical location. However, if I draw a horizontal line, then I have 2 places that could have the same, let me say that again. We have -1 mapping to 1. All right, so in this case, we have repeated y values, or 2 x values to the same y. So that is okay. This is a function. It's a function because remember it passed the vertical line test. However, it is not one-to-one though, because it's not monogamous in both directions. Okay, so the vertical line test tells you if it's a function, the horizontal line test tells you if it's one-to-one.